Hi there, guys. Last video for the spring break packet. So this one is pretty easy because we're reviewing and extending understanding and application of radicals, exponents, and the quadratic formula. And the problem that I chose was I wanted you to solve using the quadratic formula. Now, you do not have to memorize the quadratic formula. So here it is. And I'm just going to let you see everything at one time. It's just easier that way. Here's the quadratic formula right here. You do not have to memorize it. For those of you who got your Barron's book before school ended, it's in there. You can Google it. It's real easy to find, but it's right here. Negative b plus or minus the square root of b squared minus 4ac over 2a. Now, the key is to be able to look at your equation and pick out what is a, b, and c. Because once you can do this, the rest of it falls into place. So what is a? Well, remember, a is the number in front of x squared. So when there is no number, it's assumed to be a 1. So because there's no number in front of x squared, a is 1. B is the number in front of x. In this case, negative 2. So b is negative 2. And c is the last number by itself, or negative 1. And so here it is at negative 1. Remember, A, B, and C do not have the x with them. They only have the coefficient, or the number in front of x. So literally, we're going to take these numbers and plug them into this formula and then solve it. So negative b. Well, b is negative 2. So that's negative 2. Plus or minus the square root of b squared. Well, b is negative 2. So that's negative 2 squared minus 4 times a, which is 1, times c, which is negative 1, over 2 times a, which is 1. So all I did was I took these a, b, and c terms and I plugged them into the quadratic formula. Now we're simply going to just literally simplify this. So a negative 2 is just a positive 2, plus or minus the square root. We just copy that. Negative 2 squared is negative 2 times negative 2, which is positive 4. And then minus 4 times 1 is 4, and 4 times negative 1 is negative 4. But minus a negative 4 is just plus 4. We're going to simplify the inside and get 8. Then we're going to simplify that more because the square root of 8 is the square root of 4 times the square root of 2. But the square root of 4 is 2. So we can pull that out. And then we have the square root of 2 left in. Because every single term has a 2 in it on the outside of the square root, we can reduce those 3 2's, and we're left with 1 plus or minus the square root of 2. So any of these would be acceptable as a final answer. All right, this is just exactly the same, only now we're dealing with imaginary numbers. So you remember imaginary numbers where the I is involved. So you're going to do the same thing. We're going to solve using quadratic formula. So here's our equation. Unfortunately for us, this is not in standard form. It's not set to 0 like we're supposed to be. So the first thing we have to do is actually solve this to the point that it's set equal to 0. So I subtracted 8x to this side and got negative 2x. And then I added the 2 and got 17. And I solved my equation for 0. I now did the same. This is now just like the one above. I do the same thing. There's no number in front of x squared, so a is 1. B is the number in front of x, so negative 2. And c is the number in front of 17. Is the number that's left with no x, and so it is 17. Again, we do exactly like the one above. We simply plug these numbers into the quadratic formula, and then we simplify. Now, the only difference is when we solve this part, 4 minus 68 is a negative 64. Well, that's a problem because we can't take the square root of a negative. Only now we know that that makes it imaginary. So now we can, because the square root of 64 is 8. And because there's a negative in there, you have that letter I. So this is 2 plus or minus 8i divided by 2. Again, because every single term on the outside of a square root is divisible by 2, I factored the 2 out so it would cancel. And my answer is 1 plus or minus the square root, plus or minus 4i. 1 plus or minus 4i. All right, so you can rewind that. You can come to office hours. I have students who've been coming to office hours every day because I'm just working through this. And so if you have any questions, please feel free to do that. All right, so number 16, we're almost done. This is about transformations. So this, you guys were so good at this. So this should be easy. We're going from regular old x squared, which is the parent function, to doing all this to it. Remember, if I multiply a number in the front, like that 2, I'm stretching it 2 times. I'm just stretching it. When I add 3 to the end, I'm telling it that I want it to go up 3. And when I have that minus 2, remember our crazy x, everything's backwards. They're always wrong. And so we know that this looks like you would go backwards 2, but really you go forward 2 because crazy x, everything is backwards. So as soon as you see this, this probably looks really familiar. You guys did a really great job with this in class. And last but not least, this one should feel more recent because it's what we did right before we started with probability. So right before we went online. What values of x are not in the domain? Remember, anything can be in the domain, except you can never, ever, ever have a denominator that's 0, because in math, we know that you cannot divide by 0. So we're going to set that denominator to 0. We do not care about the numerator when we're talking about domain. We only want to know what makes that denominator 0, because whatever it is, we can't let it be that. It cannot be that. All right, so the values not in the domain are the ones that make it 0. This is just like the problem earlier that we did where we were solving for, we had to use the slide method to solve for to factor it. So we're going to use the slide method. So I'm going to put x squared minus 5x, and then 3 times negative 12 is negative 36. Okay, so now I'm just going to factor what multiplies to be negative 36 and subtracts or adds to be a negative 5. Well, negative 9 and positive 4 multiply to be negative 36, and negative 9 and positive 4 add to be negative 5. So the answer is negative 9 and positive 4. So we do x minus 9 times x plus 4 equals 0. But you have to remember that you did the slide method. So originally there was a 3 there. So we have to divide each one by 3. When we do, we get really lucky that this becomes a 3. This doesn't work out so nicely for us. So this becomes x minus 3, and then this has to stay. And then we remember in slide method, we never want a fraction down there. So we're going to slide that back to the very, very front. So we get x minus 3, and then 3x plus 4 equals 0. Now that's the part where you actually just factored it. So now you're going to have to solve because we need to know what the x's can't be. So we're going to set each one of these factors to 0. X minus 3 has to equal 0. 3x plus 4 has to equal 0. When we solve, we get these two answers, and those are the two answers that make our denominator 0, and therefore they cannot be in the domain. So x cannot be 3 or negative 4/3. I hope this is a good memory refresher. I wanted to go through each one because I know that it's been a while for a lot of these problems. So I hope this did a lot to help you remember what we did all year long. This is literally one learning target. This is one question or problem from every single learning target we've covered this year. So these were all questions from old tests. And it covered all of our learning targets. So we have one last unit on statistics, which I hope you will enjoy. And then we're going to start doing some major reviewing so that, fortunately for us, we don't have to worry about regents. That's amazing. But we want to do it so that we're really solid in Algebra 2 when you move forward to your next class. So the pressure of the test is off. Now you can review without that pressure, and hopefully it'll make it easier to not have anxiety about it, and it'll make it easier to actually remember it and learn it just for the sake of learning. I look forward to seeing you guys. Talk to you soon.